I welcome you all for this lecture series on 4G and 5G communication networks. In this lecture number 38, we will briefly discuss about the threats in the 5G networks. See, all you know that as 5G networks revolutionizes wireless communication with high speeds and connectivity, they also introduce new and amplified security risks. The increased complexity of 5G architecture, expanded attack surfaces, and vast IoT device connectivity create vulnerabilities that malicious actors can exploit. Threats such as network slicing, breaches, base station impersonation, and data interception compromise user privacy, integrity, and availability. To safeguard 5G networks and maintain trust, it's crucial to implement robust security measures that address these threats. This discussion will delve into the mitigation strategies for 5G network threats, exploring cutting edge solutions, best practices, and future research directions to ensure a secure and resilient 5G ecosystem. We'll see one by one. First, protecting the MEC infrastructure. MEC, multi access edge computing. We are calling it as MAC. First, in this MEC vulnerability, the multi access edge computing MEC is an essential component of 5G networks deployed closer to end users to enable low latency processing. However, its proximity to the network edge makes it more vulnerable to attacks such as unauthorized access, DDoS, that we are calling it as distributed denial of service attacks and data breaches. Next, endpoint protection. In this, to secure MEC hosts, endpoint protection software is essential. This software helps detect malicious activity and defend against a wide range of cyber threats, ensuring that each devices and servers are not exploited as entry point for larger attacks. Next, policy enforcement. Implementing service or application specific security policies can significantly reduce the risk of unauthorized access. Role based access control, that we are calling it as RBAC, role based access control. RBAC is one effective method to limit access based on the user's role, ensuring that only authorized users can interact with the sensitive MAC applications and services. Next, monitoring and visibility. Real time monitoring of the MEC infrastructure allows operators to detect and respond to threats more effectively. By tracking activities such as traffic patterns, resource utilization, and system performance, potential security risks can be identified early and mitigated before they lead to serious consequences. Next, third party security. Incorporating third party security solutions such as firewalls, intrusion prevention system IPS, and DDoS protection can further secure MEC layers. These systems can safeguard the MEC infrastructure by preventing malicious traffic, blocking malware protection, and protecting APIs from being exploited. Next, protecting the core network. This is also main important thing in this mitigation. First one, micro segmentation. Micro segmentation is a technique used to divide the network into smaller, isolated segments. This reduces the attack surface by limiting the communication between core network components, preventing lateral movement by attackers who may compromise one segment. Next, encryption. This encrypting data transmission is critical to protecting sensitive information from unauthorized access. Methods such as IP security, that is IP protocol security, and VPN. VPN means virtual private networks. VPN means virtual private networks are commonly employed to encrypt communication channels, ensuring that data remains confidential and secure across the network. Next, network isolation NAT and CG NAT, network address translation NAT and carrier grade NAT are used to isolate different layers of the network. This helps prevent direct exposure of internal network components to external threats and can help control which devices or services can communicate with each other. Next, firewall deployment. Firewalls are essential for protecting the core network from unauthorized access and monitoring network traffic for potential threats. By filtering incoming and outgoing traffic, firewalls can block harmful requests and prevent attacks such as brute force and DOS, denial of service attacks from reaching sensitive parts of the network. Next, protecting the virtualized infrastructure. Changing with the changing with the virtualization, the first point, 5G networks rely heavily on virtualized network function, that is VNFS, which introduce complexity. Virtualization allows network function to run on commonly, that is commodity hardware, but it also creates new attack surfaces. Securing these virtualized environments is crucial as a single compromised VNF can lead to widespread network vulnerabilities. Next, DNS security. The domain DNS means domain name system plays a key role in the communication infrastructure of virtualized environments. DNS level security mechanisms help block access to malicious domains, preventing attackers from redirecting traffic or intercepting communications within the virtualized network. Next, blocking compromised VNFs. To prevent the spread of security issues within a virtualized infrastructure, it is essential to deploy software that can detect and block compromised VNFs. Tools designed to prevent VM. That means VM means virtual machines. Virtual machine. Hoping and secure containers are also crucial, and these technologies help contain threats and ensure that isolated environments remain secure. Next, continuous monitoring. Continuous monitoring of virtualized components allow for real-time detection of security threats by actively tracking system performance, vulnerabilities, and potential indicators of compromise IOCs. Operators can quickly identify and address security breaches, minimizing the impact of an attack. Next, protecting CPE and small cell devices. First, encryption of sensitive data. CP means customer premises equipment. CP means customer premises equipment, and small cell devices often operate in physically unsecured locations, making them vulnerable to tampering. Encrypting sensitive data stored on these devices ensures that even if they are compromised, the attackers cannot easily access the data. Next, firmware and software validation. Validating the firmware and software during the boost processes is an important security measure. Cryptographic validation ensures that the software running on CPE and small devices has not been tampered with, preventing malicious code from executing. Next, trusted execution environment, TEE, trusted execution environment. A trusted execution environment, TEE, isolate sensitive computations from the rest of the devices, providing an added layer of security. By leveraging hardware based isolation, TEs protect critical functions such as cryptographic key management and secure processing, preventing attacks from exploiting vulnerabilities in device software. Next, device authentication. To prevent unauthorized devices from accessing the network, certificate based authentication ensures that only pre provisionized and verified devices can connect. This reduces the risk of devices being used to launch attacks or steal sensitive data. Next, location tracking. Embedding GPS chipsets in devices helps track their physical allocation, ensuring that only devices in the correct geographical areas are able to establish a connection. This adds an extra layer of verification, preventing unauthorized or suspicious devices from connecting to the network. Next, major security risk to 5G networks. Denial of services, DOS. This has got lost topics, subtopics. Denial of services, DOS attacks are a significant risk in 5G networks as they can overwhelm critical network services with massive amounts of traffic, leading to service disruption. Given the higher volume of data in 5G, mitigating these attacks is a priority. And eavesdropping, despite the advanced encryption methods in 5G, attackers may still manage intercept communications, especially at the radio access network layer, potentially exploiting sensitive information. This is a serious risk, particularly in environments where sensitive data is transmitted. Next, malware. The proliferation of IoT devices in the 5G ecosystem introduces new avenues for malware to spread. Compromised devices can be used as entry points for attacks, and malware can propagate quickly through the network, affecting both infrastructure and end devices. Next, supply chain attacks. With the 5G relying on components from multiple vendors, the risk of supply chain attacks become a major concern. Attackers can exploit vulnerabilities in the hardware or software from any of the supplier, potentially compromising the entire network. Next, misconfigurations. The complexity of 5G networks increases the likelihood of misconfigurations, which can introduce exploitable vulnerabilities. Incorrect configurations can leave the network open to a variety of attacks, such as unauthorized access or traffic interception. Next, inside threats. The increased complexity of 5G networks also raises the risk of insider threats. Employees or contractors with access to sensitive network components may exploit security weaknesses for malicious purposes, including stealing data or disturbing services. Next, lack of standardization. The rapid development of 5G technologies has led to the absence of universal security standards, making it difficult for network operators to deploy consistent security measures. This inconsistency can result in securing gaps and vulnerabilities. Next, cyber espionage. 5G, that is 5G networks with their vast number of connected devices and services such as autonomous vehicles, smart cities, and industrial IoT increase the risk of cyber espionage. A nation stated actors may target 5G infrastructure to gather intelligent or disrupt critical services. Next, interoperability risks. As 5G network integrate with the older 4G and 3G networks, they introduce risks related to the interoperability. Legacy networks may have security flaws that attackers can exploit to gain access to the entire system. Next, we'll see how to mitigate 5G security risks. We'll see one by one. Secure software development, ensuring that 5G applications are developed securely following best practices in securing software development can greatly reduce vulnerabilities. This include code review, vulnerability testing, and following secure coding guidelines to prevent exploits. Next, regular security assessments. Regular security assessments help identify vulnerabilities before they can be exploited. These assessments should include penetration testing, vulnerability scanning, and auditing to ensure that the network remains secure against emerging threats. Next, vendor collaboration. Working closely with the hardware and software vendors is critical for identifying and addressing security vulnerabilities. This collaboration should include regular updates, patches, and shared responsibility for securing the network infrastructure. Next, robust security protocols. Implementing firewalls, IDS, IPS systems, and strong encryption protocols is essential for safeguarding the 5G network. These measures can block malicious traffic, prevent unauthorized access, and protect data integrity across the network. Next, use of AI and ML. Leveraging AI and machine learning, ML means machine learning, can help predict and identify potential threats in real time. AI powered systems can detect abnormal patterns and behaviors, enabling quick response to potential security breaches. Next, employee training. Employees should be trained to recognize security threats, understand security best practices, and adhere to security protocols. Awareness programs help minimize human errors and insider threats, which are often a major source of security breaches. Next, collaboration across teams. Security should be a collaborative effort between security teams, network operators, and vendors. Cross functional collaboration can improve response times, ensure the latest security measures are implemented, and address evolving security challenges. Next, evolution of security in mobile networks. 1G to 4G security issues. Over the years, mobile networks have seen various security issues. 1G, if you are taking, vulnerable to mask warding, cloning, and illegal interception. Next, 2G, vulnerabilities included false information attacks and message spamming. And the third one, 3G, the introduction of IP based service created new attack vectors. 4G, complex network configurations and the rise of IP device led to increased security risks. 5G and beyond. 5G introduces new challenges due to the rise of IoT devices, tenancy, and virtualization. These technologies increase the attack and surface and require tailored security solutions to protect against evolving threats. Next, SDN and NFV cloud computing. These technologies have revolutionized the flexibility and scalability of mobile networks. However, they introduce new security concerns such as risk of compromised network controllers, vulnerabilities in cloud infrastructure, and threat targeting virtualized services. Next, feature consideration for 6G networks. Security in 6G networks. As 6G network emerge, they will introduce even more complex use cases such as UAV and vehicular communication, which will require more advanced security solutions. Authentication latency and massive scale of devices will present new challenges for securing these networks. Next, SDN and NFV challenges. As SDN and NFV continue to evolve, controllers and hypervisors will remain vulnerable to attacks like denial of services and resource exhaustion. Mitigating these risks will be crucial to maintaining the stability of 5G 6G networks. New concepts for security. Addressing security for virtualized network functions and cloud based services will be critical in the transition to 6G. Solutions will need to evolve to support the dynamic and multi-tenant nature of 6G infrastructures. And finally, dynamic solutions. Given the fast paced nature of 6G, security architecture will need to be dynamic, adopting the new threats and innovations in real time. Constant evaluation and adaptation will be necessary to keep up with the evolving landscape. And next, coming into the conclusion, a secure 5G hinges on proactive threat mitigation, safeguarding user trust, privacy, and national security. By prioritizing security, 5G networks protect sensitive information, prevent data breaches, and maintain the integrity of critical infrastructure. This foundation of trust enables widespread adoption and unlocks the full potential. Next, collaboration effect. So, industry stakeholders must work together to derive 5G security innovation. In the sense, effective 5G security demands collaborative efforts among the industry stakeholders, including operators, vendors, regulators, and researchers. By sharing knowledge, expertise, and resources, stakeholders can identify vulnerabilities, develop innovative solutions, and establish robust security standards. Collaborations fosters a unified front against emerging threats. Next, robust security measures. Robust security measures are crucial to safeguarding 5G networks. Advanced protocols such as an encryption and authentication prevent unauthorized access. Real time monitoring and incident responses strategies quickly detect and mitigate threats. Regular security audits and penetration testing ensure network resilience. Next, continuous innovation. Continuous innovation is vital to staying ahead of emerging 5G threats. Research and development focus on cutting edge security technologies such as AI driven threat detection and quantum resistant cryptography. Adhering to industry best practices and standards like zero trust architectures ensures 5G networks remain agile and responsive to evolving security landscape. So that's all about the mitigations in the 5G. So, thank you for your attention and engagement throughout this discussion on mitigating threat in 5G networks. Your participation is invaluable. We look forward, that is, I look forward to implementing robust security measures for a secure future. So, thanks for tuning in. It has been a real pleasure exploring 5G network security with you. Stay secure and let's build a resilient 5G future together. Thank you once again.